part of that, they work together, they pass on their genes to the next generation, they pass on their knowledge, and all these constraints, this ecology, this environment, all these forces work together to push them towards adapting at a physical level, a personal learning level, and at a cultural level where they develop their language. So some of the things that I need in this world is on the right hand here, and the things I need from the agents are on the left hand here. Now, there's after doing research on all the about artificial life simulators out there, I've come upon Polyworld. Now, Polyworld is especially useful for me because it has almost all those features from the list before. It has another very powerful thing which is not available in game engines, is that each agent, the way that it perceives the world is it actually has windows to the world, like when you're playing a game, you have a window to the world. The agents has the same thing. There's no cheating. And the other thing is, the neural network that these agents have, if you can imagine our human brains all the time, we're setting out new connections, and then the ones which are useful for us, the ones which fire, we keep, and the other ones wither and die away. So our brain is always developing, evolving. And the brains of these creatures is doing the same. So it's different to the traditional way neural networks is used in research. The only thing this program is missing at the moment is the ability for these agents to communicate with each other. But even so, these agents have been able to develop some intelligence. In this video, it's a quick demonstration of agents being able to develop swarm behavior. They look at each other and they go, hey, there's a bunch of people in there. There's got to be food. Let's travel around them. So it's some basic behavior there already. But without language, well, without further stimulus in this world, they can't take this language further. So if you look at that highlighted area, you'll see there's a bunch of agents coming together and swarming together. So the small circles there, small things which are running around little critters, the bigger green things are food patches. The brown thing there is the barriers in the world. The top part here is in each of these squares is actually what the agent sees into this world. Alright, so my immediate goals is to give these agents the ability to communicate, take away their, make sure I don't use any abstractions like telepathy, and by doing that, getting these agents to incorporate spatial concepts into the world. There's a mushroom over there to my right. Can you come and help? Waiting for somebody else to come by and help you. And each of those ideas, those basic things we take for granted, my theory is that they'll make their way into the language. And the other goal is to increase the graphics that are in the world. Because as you increase the detail, the fidelity, physics in the world, that will place extra stimulus for the agents to develop their intelligence. Alright. So, after all that, the unique thing I'm trying to do is to get them to incorporate advanced concepts, to not use any dysfunction. It's pure natural selection in the world, and working out ways where we can continue the learning process. Alright, just a little bit of speculation. Now, what's happening in this program, it's actually quite resource intensive. You have hundreds of neural networks running around in real time. And we want to increase, and if the neural network size grow, it will get harder and harder to run. So some ideas I've got are to have a client server model where you have a central server of the world. Each client is one or more neural networks, and they will explore and work in this world together. Okay. So the main point of what I'm trying to do is just take this research a little bit further. It's useful for games because it's a different way of developing AI. It has potential to create AI that will continue to grow. it's focused on communication and language, an area which takes a lot of work when it's scripted. Okay. Any questions? I've got a list of questions in case people can't think of any questions immediately. And feel free to ask questions if you have any.
How do you know that it works? Like the language, the syntax for example in the language, like I imagine you're not actually going to put in English words. So what's the test to see that it actually did develop language? Is it the physical outcome, seeing that like someone effectively managed to avoid that because someone else told them? Or is it that you actually analyse the messages that are being sent and actually recognise patterns that we can find in our own language?
There's basically three ways, and you mentioned one of them, by observation of their behaviour. The other way is looking at if the communication conveys any evolutionary advantage, and also doing statistical measures of what they're saying. If they're saying a whole bunch of things, but there's some things which keep being used over and over in certain combinations. Are there any other questions?
No other questions?
So have you thought about using any existing games, like a massive multiplayer game or something, and write bots into that could actually communicate with each other or something like that, or rather than actually using it as a test book?
I'm looking for an online game which, so it has to be something it can't be like a world tournament because I need a consistent world. So something like a massive multiplayer RPG. The only one which I found which is open source is called WorldForge, and that's where the picture came from. The thing is, there's a lot of code in Polyworld that I don't know if I'll be able to port to WorldForge, but that would be ideal.
Any further questions? Well, that was very good. Thank you, Binh. Thank you.